All right, so this is going to be a little introduction to Module 4, Lesson 3. We're going to solve systems using a method called the addition method. That's what your book calls it. I've called it the elimination method for my whole life. So if you hear those two terms, they can be used interchangeably. Your book calls it the addition method. I might call it the elimination method, but we're going to be talking about the same thing. Those two terms refer to the same method throughout this video. Okay, so just as another strategy for solving systems of equations. So we're going to see these same curly brackets again. But this time it's going to be a method where we're going to eliminate pieces of our equation at the same time, okay? And our goal is going to be to make the coefficients of one of our variables the same number, but with the opposite sign. And so this is kind of you're usually not this lucky, but this is a perfect setup for elimination. If you look at your y terms here, my y term on that first equation has a coefficient of -1. My y term on the second equation has a coefficient of +1. So we're in perfect shape here. This is a perfect setup for elimination. So what we're going to do is we're just going to add these two equations together straight up and down the column. So 4x plus 5x at the beginning there gives me 9x. The reason why this works is because -y plus +y is equal to 0. These terms will eliminate. That's what we want. And in this case, they just kind of gave it to us that way. That won't always happen, but this is what we're really looking for. On the right side, we want to do exactly the same thing. We're going to add our two equations together. So 13 plus 23 will give us 36, and we've got a new equation now, only has one variable left in it. And we can solve for x by dividing, and we get 4. Now, just like all of the other strategies that we've learned so far in this module for solving systems of equations, the most common thing that's going to happen is that we're going to get an ordered pair solution. So this is not our answer, it's half of the answer. It's the x value. We need to find the y value that goes with that. So in order to find that, we're going to take this value, we're going to plug it in for x in one of our equations there. So it doesn't matter in this one very much at all which one we plug into. I'm just going to choose the first one. But we will have to do a little bit of algebra here to solve. So, and get the y that goes with it. So 4 times 4 is 16 there. Move the 16 to the other side. These are gone. And then divide by -1. So 4, 3 is going to be our solution to this system, okay? Okay, so that first problem is really a perfect setup for elimination, but in the real world, when you're really doing this stuff, that you're never that lucky. You have to do some work to get that setup that you want. So let's look at a couple of examples where we have to do some work to make our setup for elimination possible. So in this one, if you'll notice, we don't have any coefficients of any of our variables that have the same value with the opposite sign. That's what we want there. So we're just going to force that to happen. Like if I look at my second equation here, I've got that 6x term there. Well, it's pretty easy to make that first term into a -6x. And that's what I want. I want the same coefficients with the opposite signs for one of my variables. So I'm just going to take this whole top equation, the whole thing, both sides, all the way across, and I'm going to multiply the whole thing by -6. Because -6 times x will give me -6x. -6x plus +6x will eliminate that x term. So it's going to be my first step here. Take that whole first equation, multiply it by -6. So my new first equation is going to be -6x. -6 times +2 is -12. And then -6 times +5 is -30. Okay, and you'll notice those first terms are the same variable with the opposite sign. And you'll notice in the first equation, I eliminated my y's. That's fine. If you can set it up so your y's have the same coefficient with opposite sign, that's good. It's going to accomplish your goal. But here, I'm going to eliminate my x's. That's fine too. It doesn't matter which variable you set up to solve. You just want to try to make it as easy on yourself as possible. So in this case, getting rid of the x's was easier. So that's what I went with. So adding those together, 6x plus -6x is equal to 0. 3y plus -12y is -9y. On the right side, 12 plus -30, -18. And just only a single variable. We just divide. We can solve for our y. And so that's my y value in my ordered pair. Again, it's not my solution. It's half the solution. It gives me the y that value. I need to find the x that goes with that. So how am I going to get that? Well, I'm just going to take this 2. I'm going to plug it back in for y in one of my equations up above. So I'll just choose the first one. It doesn't matter, though. You can pick the second one. You'll get the same answer there as well. So we'll plug into the first one, though. And the only reason I chose that is because the coefficients are a little nicer. So, oops. We'll solve for x. And then we'll get x is 1. Okay, so again, we got our x and a y. We do want both those values, though. We need the entire ordered pair because that's what the solution to systems of 2 variables like this look like. Okay, so let's look at another example here. Again, the same plan. And for me, going forward, my recommendation to you is to use this method, addition or elimination, for almost every system that you're not asked to solve by graphing. I don't use substitution very much, just on a daily basis. I much prefer addition, elimination. I think it's much more practical in more situations and a little faster too. So this is the method that I would recommend kind of focusing your practice on. But for this problem, again, the idea is the same. The idea is going to be to try to turn one of the coefficients of my variables to the same value but with the opposite sign. So I'm looking at the x's again here. I've got a 2x up top. I got a 4x down below. Pretty easy to turn that 2x into a negative 4x. Again, we want the same value but with the opposite sign. So I'm just going to take this top equation and I'm going to multiply it by negative 2, because negative 2 times positive 2 will give me negative 4. Negative 4 plus positive 4 will make those first terms eliminate. I want the same values with the opposite signs. So I'm going to distribute that negative 2 across the parentheses. I'll have negative 4x minus 6y equals negative 18. And I can add my equations together. So we get negative 17 on the right. On the left, we get some interesting things happening. The x's, 4x plus negative 4x, those are gone. That's what we wanted. We set it up for that. But 6y plus negative 6y, those are gone too. Okay, so everything is gone from the left side. And so that means all we have left over there is a 0. And all of our variables have canceled out. We saw this similar thing happen when we were solving with substitution, when we did our work and we had all of our variables cancel out. Okay, so we're going to need to make a conclusion. This is another special case problem. But this one, 0 equals negative 17, is just a false statement. And so we can make our conclusions just like we did in lesson 2. If we get a false statement like this, then what that's going to tell me is that there's no solution to this system. And if we were to graph these, our graphs are going to be parallel lines. They're just never going to cross. Okay, and the key term for describing this system is it's an inconsistent system. The word consistent means there's at least one solution. This one's not going to have any solution, so it is an inconsistent system. We want to be prepared for those kind of special cases that we run into. All right, so let's look at another example here where the coefficients are a little messier, a little tougher to work with. The first thing I want to note here is that there's no world in which you would ever use substitution to solve this problem. So you really don't have any choice. Elimination is really, you're just going to get a ton of fractions. So really, elimination is the only choice for a method here that's really going to work. But we are going to have to do some work to make this work out, because if I look at my x terms, I've got a 5 and a 4. I can't just multiply one of those by a number and make those coefficients the same values with the opposite sign. So I'm kind of thinking of this in the same way I do like a lowest common denominator when I'm doing fraction math in the past. I'm trying to think of a number that I can turn both 5 and 4 into. So it's the same process as what you did when you did a lowest common denominator. So in this case, we can turn both of those into 20s. I'm going to turn one into a 20, the other one into a negative 20. So I'm going to multiply this top one up here by positive 4, because that'll give me a positive 20x. Okay, down below, I'm going to multiply this 4x term by negative 5. I can't do it just to that one term, though. I have to do it to the whole equation, both sides. So I'm going to start by distributing that 4 across the top one. So I'll have 20x plus 12y equals negative 84. The second one will distribute that negative 5. That'll be negative 20x plus 25y equals positive 10. Okay, and again, we got what we wanted. Our goal here is to make those coefficients of one of our terms the same number with the opposite sign. I've got 20x, I've got negative 20x. That's what I'm looking for. Ready to add these things together now? X terms are gone because that's the way that we set it up. We forced that to happen. In the middle there, 12y plus 25y is going to give me 37y. On the right side, negative 24 plus positive 10 is negative 74. And I just divide. And I've got my y value. Just like with all of our system problems, this is not our solution. It's really kind of half of our solution. It's our y value, goes in there. We need to find the x that goes with it. Some work to do to get that. So we're going to take this negative 2, we're going to plug it into one of our original equations. Which one? It doesn't matter at all. I'll choose the second one this time. Doesn't really make any difference though. Could certainly use the first equation. We'll get the same answer. And then we'll, negative 2 over there. Okay, then we'll solve for x. So negative 5 times negative 2 is positive 10. We'll move the 10 over to the other side. Just solving for x here. So divide. So we'll get negative 3. Okay, so negative 3, negative 2 is our solution here. Okay, so hopefully that's enough to get you off to a decent start in this. Again, this is the method that I would recommend using when you're solving these systems with algebra because it's just useful in many more situations than substitution. So please don't hesitate to let me know if you have any questions. I hope you all have a good day.